next lesson video for Chapter 21, Section 2. And as always, if you want my videos in one spot, just subscribe to my channel. So this is about electromagnetism. Electricity and magnetism are different aspects of a single force known as the electromagnetic force. So if you remember when we talked about electromagnetic waves, they have the electric portion and the magnetic portion. The electric force results from charged particles. So that, of course, is like when we were talking about electricity, there's electrons flowing through a circuit. The magnetic force usually results from the movement of electrons in an atom. So in the previous video, we discussed that the electrons act like tiny magnets when they spin. Both aspects of the electromagnetic force are caused by electric charges, because if you notice, this one we're talking about, this one we're talking about charged particles, this one we're talking about electrons, which are charged particles. Moving electric charges create a magnetic field. The magnetic field lines form circles around a straight wire carrying a current. So magnetic fields aren't just created by magnets. Even current or electricity traveling through a wire will create a magnetic field because you have those charges that are moving. A charge moving in a magnetic field will be deflected in the direction perpendicular to both the magnetic field and the velocity of the charge. If the current is parallel to the magnetic field, the force is zero and there is no deflection. Okay, so when a charge comes near a magnetic field, its movement can be affected by that magnetic field. The magnetic field of loops combines so that a coiled wire acts like a bar magnet. So if you have a wire that's coiled, it will act like a bar magnet. So you can see those magnetic field lines. It looks similar to the ones in the previous video where we talked about bar magnets. A coil of current-carrying wire that produces a magnetic field is called a solenoid. So if you have a coiled wire and you're using it as a magnetic field, it's called a solenoid. If you place a ferromagnetic material, remember from the previous video, that was just a material that can be magnetized and have its domains aligned easily, like iron. That's where ferro comes from. Such as an iron rod, inside the coil of a solenoid, the strength of the magnetic field increases. So if we have the coil, we have a magnetic field, but if we insert an iron rod, we strengthen the magnetic field. The magnetic field will also increase as the number of loops increases. So if you look, here we have a certain amount of loops. Here, if we increase the number of loops, we're going to have a stronger magnetic field. An electromagnet is a solenoid with a ferromagnetic core. So the coil itself is the solenoid. Once you insert the iron rod or ferromagnetic material, it's referred to as an electromagnet. Changing the current in an electromagnet controls the strength and the direction of the magnetic field. Okay, so when we have it attached, because of course there's electricity running through the wire, so it needs to be attached to something. And so if we change the current running through the wire, we can control the strength of the electromagnet. So, section assessment. Besides a magnet, what can create a magnetic field? A wire carrying current. A wire carrying current, or a wire carrying electricity, you could say either. Number 2, how is the magnetic field of an electromagnet controlled? Well, for the electromagnet, you can change the current. If you increase the current, you increase the strength of the magnetic field. So if you increase current, you increase strength. How does a ferromagnetic rod inside a solenoid affect the strength of an electromagnet? Well, once you insert the ferromagnetic rod, that increases the magnetic field strength. That increases the magnetic field strength. What is the effect of a magnetic field on a stationary electric charge or on a moving electric charge? Well, on both of them. On the stationary charge, it can cause the charge to actually start moving. On the moving electric charge, it can cause a change in the motion. It just depends on what charge it has and what magnetic field it's coming into. So it can cause a stationary charge to move, and it can change the motion of a moving charge. And then last one, why is it a good idea to have the coil of a solenoid wound closely with many turns of wire? Or the more turns of wire you have, the stronger the electromagnet. The more turns of wire, the stronger the electromagnet. So hopefully now you have a better understanding of electromagnets, the ferromagnetic core, and a solenoid.